Good morning, guys, and welcome back to 11.3. This will be our last section that we're going to learn before we have a quiz on 10.1, 10.2, and 11.3. And like I said, check Google Classroom for the dates of that quiz for your class. What we are going to be learning about is very similar to where we left off when we started the end of 10.2. And 11.3 is all about the area of a sector. The ratio of the area of a sector. So what is the area of a sector? The way I always like to think about it is the area of a sector is like if I gave you a slice of pizza and asked you to find the area of that. Okay, you're finding the actual space, the actual surface area of that slice of pizza. So the area of a sector is just a slice of pizza out of a whole pie. And the formula that we're going to use to that, if you look, it says, basically we have our proportion, we have our equation. The easiest way that I like to write it is we take our degrees, so it says x over 360, so we take our degrees of our sector over our total degrees equals the area of our sector, so the area of our slice of pizza, over basically the area of the whole pizza. So it's still part over whole, part over whole. Degrees of our sector over 360, the area of our sector over the area of the whole thing. Now the whole thing is a circle. So what is the area? Just pi r squared. So the best way, if we like to write this a little bit neater, is degrees over 360 equals sector area all over pi r squared. And we're really just going to figure out the pieces and plug in here, find the answer. Example 1, find the area of the shaded sector. So again, my formula, degrees over 360 equals my sector over my area of my whole circle, which is pi r squared. We are finding the area of the shaded sector. So our unknown is going to be our sector piece. You can call it whatever you want. I'm just going to call it x. That means that everything else we must be able to figure out. We can only have one variable. So what is our degrees associated with our sector? 135 degrees. Okay, that's our arc associated with our sector that is shaded. And then it has x, 135 over 360 equals x over our area of pi r squared. Pi stays the same. What is the radius? Let's look at the diagram. They give us right here that this piece, which is the radius, is 6. So I'm going to plug in 6 for the radius, and don't forget the formula is pi r squared. And now we are going to solve this. The way I recommend solving this is I would always do some of the math first. So pi times 6 squared is really just 36 pi. So I'll have 135 times 36 pi, which is going to give me 4,860 pi. And that's going to be equal to 360x when I cross multiply the other way. Now, I'll divide both sides by 360. And what is that going to give me? X equals 42.41. So what does that mean? Remember, we were solving for the area of the shaded sector. So what is my area going to be for my shaded sector? 42.41. It's area, so it's going to be units. In this case, our units are centimeters squared. It's squared because it's area. Okay? Figure out the pieces, plug into the formula. And remember, there are try problems for each one of these examples. They're on your notes, and then you can check out the worked out PDF of the notes and see how you did on those. Okay, example 2. Directions look a lot similar. So remember, we're going to find the area of the shaded sector. So degrees over 360 equals area of my sector over pi r squared. Again, I'm finding the area of the shaded sector, so my variable is going to be what I just outlined in red, my area of my sector. So what I need to figure out is, what is the rest? Well, they give me my radius, it's 11. Remember, there can be a case where they might give me the diameter, and I have to know to divide it by 2 because I want to use radius here. The area formula uses radius. So pi times, in this case, they give me the radius is 11, so it makes my life a little bit easier. So I'll just have pi times 11 squared, and it's degrees over 360. Here's my only issue. I am finding the area of the shaded region. If you notice, they give me the angle associated with the unshaded region. So how am I going to figure out the angle of the shaded region? Well, a circle has 360 degrees. 360 minus my unshaded region should give me that my shaded region is 295 degrees. So that's the 295 is going to be my angle, or my degrees, I should say. Remember, you only want to use the angle that's associated with the shaded region. So not the 65, it will be 360 minus the 65. Okay? And now you're going to do the same thing as last time. You're just going to cross multiply and solve. 360x equals 11 squared times pi times 295. Keep it in terms of pi if you can. Is just going to be 35,695 pi. And then all I'm going to do is get my x alone. So divide by 360. If you are not getting the same numbers as me, be careful, make sure you're using parentheses, okay? And, you know, contact me if you have any questions. So my x would equal 311.5 inches squared. But what is x? More importantly, it's the area of the sector is 311.5 inches squared. Okay? Make sure you're using that formula. Make sure you have the radius. They're not giving you the diameter. Sorry about that. And also make sure they're giving you the angle associated with the sector that you're trying to find. Okay, and we have 2 more examples we're going to look at. Let's look at some word problems here. Example 3 says, you are at your favorite pizza place, and they offer 2 different sized pizzas. Okay? The medium pizza has a 12-inch diameter and is cut into 6 congruent slices. The large pizza has a 16-inch diameter and is cut into 8 congruent slices. Which slice has a larger area? So let's see if we can figure this out for a second. You are at your favorite pizza place and they offer 2 different sized pizzas. So I have a medium-sized pizza and I have a large-sized pizza. The medium-sized pizza has a 12-inch diameter. If the diameter is 12 inches, then we know the radius is 6 inches. Okay? And it is cut into 6 slices. Let's see how we use that in a second, but let's just hang on to that. The large pizza has a 16-inch diameter, which means its radius is 8 inches, and it is cut into 8 congruent slices. So there are a few different ways that we can do this. The easiest way that I always recommend is that when we plug into our formula, we always do, when it comes to the degrees, part over whole, right? When it comes, so normally our formula is going to be degrees over 360. So this is just saying part of the circle over the whole circle, the number of degrees over the whole thing. Well, if we are going to take our pizza and divide it into 6 congruent slices, aren't we talking about which slice has a larger area? Aren't we talking about 1 slice out of 6? And if the large pizza, we're going to cut into 8 congruent slices, and we want to find the area of the 1 slice, isn't that part over whole really just 1 over 8? Okay? And now, what we're going to do is our formula says part over whole equals area of the sector over my area of my entire pizza in this case. So area of my sector is basically what we're trying to find for each one. And I'm going to use different variables just to make it easier. And then what is my area of each one? Well, they give me my radius, so it's just going to be pi times 6 squared for this piece, pi times 8 squared for this piece. And what I can do is I can cross multiply and solve, and I'll get my area for my medium slice is 18.85 inches squared. My area for my larger slice is 25.13 inches squared. So which slice has the larger area? The slice that has the larger area is going to be my large pizza. And this makes a little bit more sense, but remember we're cutting them into different numbers of slices. So whenever you do these formulas, the entire time I've been saying part over whole, part over whole. Another way, just to kind of step out, if you understand what I'm doing, that's fine, but if you're a little confused, you could have had, instead of 1/6, you could have said, okay, there are 360 degrees in a circle, divided by 6 slices, so each angle is going to be 60 degrees. So you could have put 60 over 360. Guess what that reduces to? 1/6. You could have done the same thing for the other one. 360, there are 8 slices, divided by 8, figured out my angle measure. But guess what? It's just going to end up being 45 over 360, which is 1/8. So if you can just remember part of a whole and jump to these two, then you're good to go. Okay? And like I said, look through my work, make sure you understand it. I'm just using that formula every time. Okay? And finally, last but not least, let's look at our last example. Our last example says that a rectangular wall has an entrance cut into it. Okay, so we can see we have our little entrance cut into it here. And it says you want to paint the wall to measure to the nearest square foot what is the area of the region you need to paint. Okay, so we're painting the wall, not the opening. So we basically need to figure out the area of everything I just outlined in red. In my opinion, the easiest way to do this is always find the area of the entire thing, and then you could subtract off the area of. Okay, sorry about that. So what we are going to do here is, in order to figure out what we need to paint, we are first going to find the area of the entire thing. So we're going to think of this problem a little bit differently than the other ones, that we're not plugging directly into that formula. We are going to just find the area of the entire rectangle. And what's the area of the entire rectangle going to be? 36 by the whole thing is going to be 16. So if we do, sorry, not 16, we have the 16 plus the 10, so it's going to be 26. So our full area is going to be 36 by 26, which is 936. And then what we can do is subtract out the middle doorway piece, and that will get us the area of the wall. Now the middle doorway piece is divided into, to find the area of each one, we can first find the area of the rectangular piece, and then we can find the area of the semicircle and subtract them both from 936. So the area of my rectangle, what is that going to be? Well, we know the piece across is going to be 16. And let me clear off this diagram so we can see a little bit better. So we know that this piece across is going to be 16. And they tell us on the side that our height is 16. So the area of this square piece of the doorway in the middle is just going to be 16 by 16, which is 256. But we still need to find the area of my semicircle. Well, if the bottom piece of a semicircle is the diameter, and that is 16 feet across, then we know the radius is 8 feet across. So, we want the area of a semicircle. We're going to take circle formula, area is pi r squared, so pi times 8 squared. But are we talking about a full circle area here? No, it's a semicircle, which is half of a circle, so it has half of the area. So I'm going to take it and divide it by 2. Okay? And if you do this in your calculator, 64 pi divided by 2, you're going to get 100.53. So how do I finish that? What is the area of the region you need to paint? So this area all in blue. We're going to take our total area of 936, subtract off our square piece, our square doorway, 256, subtract off our semicircle, 100.53, and our total area is just going to be 579.47 feet. It's area, so it'll be feet squared. Okay? Once again, you can look at your written out copy of your notes, work through these, write them down. You can complete your homework. Check your answer key homework the next day. I'll still be giving you feedback. And check Google Classrooms for deadlines, dates, and quizzes. If you have any questions, email me, let me know, and we'll see what we can work out. Have an awesome day, guys, and please keep up the good work.